Okay, I think that's good. Yeah, that's recording. Okay. So, so our warm-up we just did. So, I'll go over the learning objectives really quickly. Our first learning objective is to investigate solid and liquid behavior. So we did that, we had a lecture on that, and we did that through our lab. Next week we might have time for a virtual lab. I think that would be a lot of fun. So I'll try to remember to put that in the lesson plan. So our assessment methodologies will be quiz and lab report. So our lab report is due next Friday, but we've got time to work on it today. And then our quiz will be probably the Monday, Tuesday of the week after. And then we're always wondering, how do the microscopic properties of solids and liquids affect their macroscopic behavior? So we're going to be learning more and more about that. And then our agenda for today, we finished our Achieve article. We've got our discussion section to work on right now. Then you have time for your lab report, and then you're going to do watch a little fed up. Okay, so this beaker, right, has what in it? Salt. Okay, and this is crystalline sodium chloride. So that's the technical term, right? So the first question in your discussion asks, can crystalline sodium chloride be recovered? What does recovered mean?
Like the treatment you get it.
Yeah, purified from, obtained from ocean water. And how do you know? So, can we get crystalline sodium chloride from ocean water? Yeah, how do we know?
So we did it.
Right. So, one good answer to this, and again, don't write down this sentence or don't look at the video that I'm going to post on YouTube. We noticed that I've been posting lecture videos on YouTube, right? And they're all on Google Classroom. So if you're gone and you miss a lecture, right, you can just tune right in, okay? Might not be the most compelling thing you're watching or even close, but it'll get the job done if you're not here. So, can crystalline sodium chloride be recovered from ocean water? How do you know? One answer would be, we determined that crystalline sodium chloride can be recovered from ocean water because a powdery white substance whose appearance was consistent with that of solid sodium chloride was recovered after ocean water was evaporated from our beaker, right? Something like that would totally work. What is the percent mass of salt in ocean water? How do you know? Okay, so two different things there, right? You've got your accepted mass, and you know that the accepted percent mass of ocean water, the accepted mass percent of sodium chloride in ocean water is 3.5, and you know that because other people have done research, but you've also got your own number, right? And your own number says, well, given the fact that a bunch of this salt, what did it do? We were boiling this thing, and what happened to some of the salt? Did it all stay in the beaker? No, what happened? It sort of popped, right? You didn't get to see this unfortunately, but it sort of popped and exploded, and it wound up on the countertop. So there was all this salt that Ms. Sandoval and I were cleaning off the countertop and off the hot plates. So some of the salt left, right? So what is the mass percent of salt in ocean water? Well, you believe the recorded evidence of 3.5%, the recorded number, the accepted number, and then you say to yourself, our number was a little bit lower than that, but that's okay, right? So we can tell that there's at least some salt in ocean water. We'll believe that the 3.5% number is reasonable, okay? And maybe we'll come up with a better means of studying that ourselves. So, and of getting closer to that number. So why do you think your experiment result is different from the accepted value? We just said, what happened to the salt as it boiled? Yeah, some of it just literally leaped out, like popped or exploded out of the beaker, all right? Okay, so that's what you have to put in your discussion section. So one last little bit of business. The discussion section is the last paragraph of your lab report. So generally speaking, what's the last paragraph of your essay? You're writing an essay, and what's your last paragraph? Right. So scientists call the last paragraph the discussion section. Does the discussion section have some conclusions in it? Yeah, sure. It's also got just some general discussion, right? We're not just concluding, we're reflecting on our results and thinking about their implications. So you say to yourself, okay, so I did this research, right? And you're like, man, I would love to have, so the reason we used the beakers was that the beakers allowed us to do the experiment fast, right? We got through 32 ocean water experiments in 2 days, okay? And our turnover had to be quick. We don't have that many little beakers, so we had to turn the beakers over every couple hours, right? So one mod comes in, does the experiment goes, the beakers evaporate, then the beakers have to be weighed, then they have to be cooled, then they have to be washed, then they have to be dried, then the next mod comes in, you repeat the process all over again, right? So we used a methodology that allowed us to get the work done. We didn't use a methodology that allowed us to get the most accurate result. So, you might ask yourself, what could you do, right? What could you do in order to get a more accurate result? So the problem with our process is that we used something that starts with a B. The last step, we boiled the water, right? And so that disrupts the sodium, like the crystalline structure. Our salt looks like a powder, right? So does anybody remember what you can do if you want to wind up with really nice salt crystals? I may have talked about it. So if boiling is really disruptive, what could you do with ocean water if you just want it to slowly evaporate to give really nice salt crystals? That ends up being what now?
Leave it out.
Yeah, you could literally just leave some salt water out in sort of like a shallow dish, and after maybe a day or two, it would evaporate and it would just leave nice crystalline sodium chloride, right? But that experiment, are we going to do 32 of those experiments in 2 days with a limited number of beakers? No, right? But this is the kind of thing that scientists reflect on. They say, hey, you know what? My methodology had this advantage. It got the work done quickly, but it also had the disadvantage of giving me an inaccurate number. Result. Okay. So we could change that methodology, right? That's why we call it in science a discussion section, not just a pure conclusion section, because we have more going on than just conclusions. Okay? We think and we speculate a little bit. Speculate means to
Yes.
good. Make like an educated guess, right? Like I'm guessing based on what I know that, you know, the number we would get, like the result we would get if we just left our beakers out to dry in air would be closer to 3.5%, okay? Than the result we got through boiling, all right? Okay, so I think that's 10 minutes total, including the little chat we had up front. That's all for this. So you're gonna have the next 30 minutes or so to work on your discussion sections. You may or may not have any lab report writing time next week during class, but you'll definitely have, you know, how like the weekend and weeknight time to get the lab report done. Lab report is due next
Friday.
Yeah, everything's due on Friday, right? Okay, so that's it for now. We're gonna have fed up documentary process notes after that, and I'm gonna be calling people up for grade checks. All right? Thank you, scholars.